Hello? Okay, good. Hi, I'd like to introduce today's seminar. It's my pleasure to introduce the speakers coming up. Today's seminar is titled Environmental Odors, Best Practices for Monitoring, Methods, Handling Complaints, and Human Health Risk Assessment. My name is Pat Wong, and I'm the manager of the Indoor Exposure Assessment Section. Now, during the seminar, for those of you online, first, thank you for joining us. You can email questions and comments to sierrarm@calepa.ca.gov. And for those of you in the room, while people are writing down that email address, I just have a couple of housekeeping announcements. The drinking fountain and restrooms are located out the doors at the back of the room. Go to the left and then left past the glass sculpture hanging from the ceiling. The drinking fountain and restrooms are located there on the right. In the event of a fire alarm, we are required to evacuate this room. Please take your valuables with you and do not use the elevators. Evacuees will exit down the stairway and possibly to a relocation site across the street. Should we have to relocate out of the building, please obey all traffic signals and exercise caution crossing the street. Okay, I guess before introducing speakers, I'd just like to tell you a little bit about our topic today. Odors have been a big concern for CARB, mainly because we do get a lot of complaints, and a lot of sources of odors, such as dairies, foundries, industrial facilities, are sources that we are familiar with and in some case regulate. As part of this process, one of the first things we did was talk to a lot of the air districts and ask them what they do. And almost every single air district, when I asked them about do you guys get odor? Oh yeah, odor complaints are like the biggest issue we get. We get more complaints about odors than everything else. But then when I asked them what the source is, that's where there's changes. Some cases it was foundries, some cases rendering plants, some cases landfills. So even though odors were a big source, you can see there's a variety of different possibilities depending on where you live. The other thing I learned when I talked to the different air districts was that there wasn't a real consistent way of monitoring, taking down complaints. A lot of them says, well, there's not best practices for a lot of these, and that's kind of where this white paper came along. And both Scott and Mel will talk about what they found during their research. So just for introductions, Mel Suffett is a distinguished professor at UCLA. His teaching includes fate and analysis of odorous and toxic chemicals in the air and water environments. His major areas of air pollution research include odor nuisance evaluations in urban areas and specific industry sites, development of an odor monitoring system using odor panels, and development of analytical chemistry systems using GCMs and GC sensory methods to determine the components of nuisance odors. Scott Brathwaite recently completed his doctorate at UCLA, congratulations, in environmental sciences and engineering. His prior degrees include a master's in environmental health from Harvard and a bachelor's in chemistry from Brigham Young University. During his 20 years of professional experience, he has contributed to exposure, risk, and alternative assessments for US EPA, DuPont, Clorox, and DTSC. So without further ado, Mel?
Thank you for the introduction, Pat. I have one T in my name, but that's okay. And Scott, his second name is spelled correctly. That's been one of my major problems, is spelling his name correctly. But Scott and I worked very hard on this project. It was a very enjoyable project because we learned a lot as we did it. The whole question is, environmental odors, best practice for monitoring methods, handling complaints, and human health risk assessment. I'll present the beginning part of it, and Scott will do the risk assessment part, and then we're both here to answer questions. Without Scott's writing ability, this project would not have been finished on time. What is a white paper? This is the first question I asked when this project came up. I came up with the objective to improve, to improve California's response to odor complaints through science-supported methods. The key question here is, what are the science-supported methods? Because odor is sort of not, quote unquote, as understood as science is in terms of instrumentation. We reviewed the literature, we determined the best approaches to understand an odor nuisance, and we are suggesting ways forward to reach objectives to control the problem. We address this in 7 categories, and I'll go through these categories. Each one, you'll see the number written up on the top of the screen to know which category we're in. So to begin with, we have introduction of what is odor perception, how it works, background on odor nuisances, complaint data management, screening level approaches, refined investigation and recommendations, human health risk assessment, and conclusions, best practices, and research needs. The beginning of the discussion and the end of the discussion is, I hope, what you really remember, because the basic questions are asked at the beginning, and at the end, we have our conclusions. So first, introduction to our nose and how it operates. There was a Nobel Prize by 2 professors about 10 years ago on understanding how this works, and this comes from their work. So here is our nose, and obviously we want to smell something like flowers or strawberries as our thing that we're interested in enjoying. Here is our olfactory system, the olfactory bulb. The olfactory bulb has different pathways. Notice that these are the olfactory acceptors. There's a lot of olfactory acceptors. Odor comes past the olfactory acceptors, and certain ones combine with these receptors. It could be this one, and this one to give you one odor. There are thousands of odors, and we have that ability to smell thousands of odors. Canines have a better ability to smell than we do. That's why you see them walking around the airports when people come in from overseas trying to smell if they're bringing food into the United States, as an example. Here is the bottom of the olfactory nerve. The odorant binds to a receptor. The odor receptor is here. You can see that this is a blow-up. And I've seen pictures of fluorescence lighting up. This is what the Nobel Prize was, lighting up pictures of this bulb went off, that's that odor. That's where we are now in trying to understand the odor. The physiology is not that well understood. Here is something that recently came out. This is a 2019 article. It describes the biome and how important it is to our sense of smell. Here are the birth of a child, and what happens. All of these things are the first type of organisms that get into the nose of the child. This biome develops. If this is a normal birth, this way. If it is a cesarean birth, it doesn't happen this way. It happens from different areas of the environment that the nose that comes out from a person builds up with organisms. If it has the right mixture of organisms, a healthy nasal cavity, there's Staphylococcus and other organisms here that usually combine, and they help you with the odor perception. Also, they have an odor of themselves. So when you smell something, your biome plus your olfactory nerve is working in combination. And that's something was just published in this year. There is also, if there's problems here, or if they get a wrong combination, they can be anosmic, meaning they can't smell properly. And it's not something it's not something that's genetic in the olfactory, it could be in the nose. There also are olfactory problems with anosmic people, and you always want to know if you have an odor inspector whether he's anosmic or not. That's very critical. And it's about 3% of the population in the United States, they say, are anosmic. Okay, olfaction. Mixture, 1, 2 odor notes, 3 or 4 for experts. In other words, you can easily separate 1 or 2 odor notes if you have a glass of wine and you smell the wine and sift it. The experts can maybe come up with 3 or 4 odor notes. More than 4 odor notes is very, very difficult for our nose to comprehend simultaneously and call out. Detection limits, parts per trillion. We're talking about nanograms per liter of air to be able. We are better smelling something than chemically measuring it. We have to concentrate the chemicals to measure it. For smell it, we can do it without that. Variability, obviously, age. The older you are, like me, the worse your sense of smell is, the worse your sense of taste is. You start salting your food more. Lifestyle, culture, sex. Women in their early 20s have the best sense of smell. It's been shown in the literature over and over again. Prior exposure is important. There's obviously health status, and prior exposure includes how you were brought up and where you were brought up, what kind of foods you ate, what kind of environment you lived in. So all of these are important. And this is below a normal range, which is the asthmatic. And I always get messed up with the word, the people who can't smell things well. Okay. Background on odor nuisance, terminology. This is the key message. Each odor is caused by a chemical or chemicals. That's it. You have to know what the chemicals are if you want to remove them from the place where there's an odor nuisance or understand it. That's the thing I'll always return to. You can describe an odor as, for example, they call it odor notes. And all of this terminology comes from the wine, beer, food industry, perfume industry, who've been using this for years as their methodology to understand odor and develop the perfect perfume, the perfect deodorant, etc. So, an odor note, there's an example, rotten vegetable. That's not a good odor note. If it was a perfume, we'd be looking for a very nice, sweet smell, let's call it. Odor intensity, there's different scales. This is one scale that I have been using. It's a 7-point scale. It's called an odor intensity scale, and I'll show you more about the specifics of it shortly. This describes the odor profile method, which we're going to be recommending to be used by inspectors as well as the general public. It is now used in the water field for drinking water to protect, and there's a standard method for it, to protect drinking water supplies. There's also a hedonistic tone. I call this the stink factor. Oh, I hate the smell of that, it stinks. They don't define the odor, they don't define the intensity. It's a feeling, it's not good, we have to take care of it. This doesn't tell you what the odor is and how to control it, but it's something that aggravates people, and that becomes the word nuisance. Dilution to threshold, the odor disappearance. You want to see the odor, if it's there, disappear by treatment or by control at the source. There is a method to do that. It's a dilution to threshold method. It's called olfactometry, or using the nasal ranger, and it works with odor units, a dilution to threshold. There's no characteristic of the odor note, intensity, even the hedonistic tone involved. It's just, is it there, and how it dilutes to threshold. Models for odor dilution have been devised and are used routinely. Everybody knows hydrogen sulfide smells like rotten eggs, and everybody in the industry has used that as a sentinel following that. It doesn't work for every other kind of odor. As you'll see, hydrogen sulfide is only one kind of odor, rotten eggs. Each chemical has an odor detection threshold. Odor detection threshold C at 50. The 50 means that 50% of a panel says that's what the threshold is, by taking an average and a standard deviation of the values that they get on an intensity scale. That's how you get the odor threshold concentration. I'll show you examples of that shortly. So this is the background terminology I'm going to be using to describe things. The first thing is an odor wheel. This odor wheel comes from Vancouver, where they've, in 2019, the latest one, where they've taken all the other odor wheels that have been developed, and they've been developed, the food industry, the coffee industry, the water industry, and I've been involved with developing it in the air as well. And they come up with a central category: earthy, prepared food, fishy, rotten, offensive. That's where the rotten vegetable comes in, and the hydrogen sulfide. Medicinal, chemical, fruit or vegetables, and floral. This is the one we like. And outside are more descriptions of the example. For fishy, it says a permanent solution, urine and ammonia, and dead fish would be in that fishy category. So it's a subcategory. The third level, which they don't show, are chemicals that have been proven to be that odor at a location, or chemicals that have that odor, one or the other, okay? Here's an example of something that a former student working at the ARB in Southern California, Jane Curran, worked on. She developed an odor urban wheel. It's only in her thesis in 2012, but it still works. So here's the categories. I'll go over them a little more in depth, you'll see in a second. Here's the secondary categories, and here's the third set, which gives the chemical associated with those odors. So here's the picture of the way I worked with Jane on this material. So we have nose feel. That's something, there's something in your nose that like feels pungent. It's annoying, but you can't define an odor for it. That's another kind of thing that happens with odor. Acid, metallic, fuel, solvent, plastic, burnt, restaurant, fragrant, earthy, musty, fecal, sulfur, rotten vegetable, natural gas, rancid, sour, dead animal, putrid, fishy, ammonia, and this is the nose feel. Now this wheel was based upon looking at all the complaints in a database for 20 years at South Coast. That's where we came up with this in terms of the most prevalent materials. Here's an example in the fishy ammonia category. So we have fishy, fertilizer, and ammonia in the fishy ammonia, and here's the chemicals. Fishy, trimethylamine, dimethylamine, methylamine, and ammonia for ammonia. If you have fish and you let it sit out in the open, it will smell fishy. These are the chemicals that are causing that fishy odor. You take each of those chemicals, put them in a solution, and smell them, they will smell fishy. In this case, it could be a combination of all three. Sometimes it might be one. This is the way it operates. Now, intensity. There's two scales of intensity. One is a Stevens power scale that almost all of them work since it's a log-log concentration scale. The other one is the Weber-Fechner law, which was done in 1856 by Weber, who was a student of Fechner in Germany. This is how long ago. He found intensity, which turns out to be logarithmic in the sense. Your sense of smell is logarithmic. Your sense of vision is logarithmic. You could see the moon. If it wasn't, you couldn't see the moon. Decibels is logarithmic in terms of sound. Your nose works the same way. It's a logarithmic system. So we have the intensity is proportional to the log of the concentration versus the odor threshold concentration. And this is the Weber-Fechner law, and we use this, as you'll see, to define intensity for each particular characteristic. Not for a whole thing, for each characteristic. Okay? Now here's sort of the bottom line that shows what's going on. Here's an intensity scale. Here's the logarithmic concentration in nanograms per cubic meter in air. Here's a bunch of chemicals. Notice ammonia is out here. Not very concentrated. You have to have a high concentration of ammonia to smell it. The 1 point we have determined as the odor threshold concentration. So here's where 50% of a panel would depict it. Above it, above. So you can start out with a concentration here. You can follow the dilution of that material. So you can measure the concentration during dilution, and then you can measure the intensity. So there's that one. Skatol, which is fecal odor, which is one of the fecal odors, is right over here. That's at the bottom. And then there's a strange kind of odor. Here, look at this one. It crosses. The slope of the lines, you notice, are not the same. They cross over. So if you do dilution and you have these two in a mixture, this one might show here, and over here, the other one might show, because its odor threshold level is lower. This is the complication that you're really facing when you're looking at odor. And we evaluated this by having an olfactometer, which is a great dilution machine, and smelling the olfactometer, knowing the concentration, measuring it, knowing the intensity from an odor panel to develop this. Odor detection threshold concentration. There's two methods to determine it. We use the odor profile method, and we have a calibration based upon sugar solutions. Dilution of sugar solutions. You can use your sense of taste to correlate with odor. High, moderate, low. And in between those are the 7-point scale. So several dilutions, panel calibrated, so on high, medium, low. The panel is assigned intensity. 0, there's no odor. 1 is threshold. And it goes 2, 4, 6, 8, 10, 12 for each dilution. It's log concentration. It's in a linear calibration. I just showed it to you on the last slide. The intensity 1 yields the odor detection concentration by that method. Now, that is not the best method to determine the odor detection concentration. The triangle forced choice method is we have dilution sub to supra threshold. In other words, you keep diluting until somebody can't smell it, and you use panels that are calibrated by N-butanol. This is an ASTM method. N-butanol has been used as a standard in the air system for odor dilution. We find, and we have data to prove it, that it's just equivalent to the way we can use sugar, and people like the taste of sugar than they do like methanol if they're out in the field, and we have seen that. Panels select between 2 blanks and an odor sample. Thus, they have a 33% error that's in there. With this system, you really have a very large standard deviation for a logarithmic thing. It's a big area. Panel statistics yields the odor detection concentration. This is the best method. This method we have used, and it seems to work, and I'll show you why soon. Okay, here's the example. Here's the odor detection by the OPM method versus the literature. The literature is done by this other method. Notice the ones in parentheses is the literature. Notice that they have tremendous ranges. There is not a very good set of standards that we could say, look at this, 30 to 40 to 4,000, 0.6 to 10, that's a smaller range, 0.04 to 3, that's a very large range. So you have this logarithmic concentration, which gives you a large range and a large error. This has to be done correctly by a standard group of people who are really trained and understand how to do it. It hasn't been done. It's been done in many, many studies and many compilations. But The odor threshold, the odor threshold concentration, 50%, were found by that other slide I showed you. These are the values. They fall within the range here. That's the best we can do. These are very common odors that we find as odor nuisances. Hydrogen sulfide, rotten eggs. Methyl mercaptan, rotten vegetable. Dimethyl sulfide, rotten vegetable. Notice that the methyl mercaptan is lower than the hydrogen sulfide, and many times what they're calling rotten eggs is really the rotten vegetable, and this is the controlling influence. Dimethyl sulfide. Dimethyl disulfide becomes a garlic. All of these are sulfides. Then the musty odors come in. Notice the musty odors, 0.002 micrograms per cubic meter. We're talking about nanograms per cubic meter materials. Then here's the indole, and there's the skate oil. Notice the skate oil. Look at that range, and we found it at the top of the range, not at the bottom of the range. There's a reason for that. I'll just tell you a secret. Certain Tedlar bags love to absorb skate oil. It's been in one of my students' thesis. We haven't published it yet. Okay, here's compilations that were done by many different people. Notice, AIHA, Industrial Hygiene Group, looked at the literature. Texas compilation, 189 hazardous air pollutions were looked at. 21 odorants were looked at in one study. 84 food aromas were looked at in another. Need a US EPA IRIS-like repository for curating these values and really understanding it. It's not solid yet. Okay, next, number 3, complaint data. You look at this chart, you say, gee, it went down in certain years. These are years that are difficult to see. Guess what the blue is? The blue are the odor complaints. These are the other complaints that the district has. But it's the odor complaints control. Notice the odor complaints have gone up here in later years. They reached a low in 2010 for some reason, but the odor complaints are the controlling problem that the air districts have. Thus, they want to help solve. This white paper is trying to get on that idea. Here's the background challenges. Odors are typically mixtures of odorants. They are not one chemical. If you have sludge, it's going to give you all kinds of odors that are different. If you have trash going to a landfill, it's going to give you rancid odors, it's going to give you sulfur odors, it's going to give you all kinds of odors. That's the problem. Odors are typical mixtures of odorants. That's why I have this in bold. Intermittent and transitory odors at certain times of the day. If the landfill's not operating at night and the wind is not blowing correctly, the odors will go down. Variation of sense of smell, complainants and investigators. The investigator as well as the people complaining have variability sense of smell. Worries that odor indicates unhealthy air, people get upset. Does this cause any kind of toxic effect? I'm smelling this all the time. Overlapping odors from a variety of sources. Milpitas is a perfect example that's going to be studied by the San Francisco Air Board relating to this question from a series of sources. No instrument fully mimics the nose. There is an e-nose, I'll talk about that later, but no instrument has demonstrated that it can deal and show what our olfactory can do. Background regulations. We looked around, Scott looked around the world for regulations. The British Commonwealth has laws on nuisance. They deal in private and public. That's what their law is about, private and public. 28 countries reviewed it by Brancher. His key findings were most delegate enforcement to local authority. Most delegate enforcement to local authorities. In other words, it's not the US EPA doing it, it's the local people doing it. Some set of odor specific, some set odor in specific limits. They look at a particular odor, H2S should be below this value. And H2S is the one that usually is picked out. Many set intensity limits based upon this idea of dilution, odor units. Germany and Japan have approached this in Europe and Asia, and they influence those markets working on this odor dilution system, where you should have a certain amount of dilution from the source. But if you have a mixture, I showed it crosses. What are causing the odor? How do you control it? You don't know. You know, yes, it's there, no, it's not. So it's a supplementary thing to what we've been talking about, yet it's been used as the primary odor detector around the world. United States, 1970 and 1990 Clean Air Act, US EPA, considered regulating odors, but decided not to, left to the states to control odor. That's why we're here today. So Scott made phone calls to a group in France. I think this is, huh? Oh, I'm sorry, that's the United States. I got it backwards. In the United States, Colorado and California particularly. We also looked in France at the French group. I work with the French group very closely. And Australia. Australia really is pushing ahead of all of us in terms of getting things done in relating to odor. Complaint data management. Here's the problem. Database developed in-house. Everybody has a different database. Turned out San Joaquin Valley AQMD has an expensive phone-friendly database that really works better than most that we've seen. Colorado tracks complaints and all air investigations and have a good tracking system. So those are examples to maybe use in California for your work. Database commercially available, currently use Microsoft SharePoint or Acela, previously used SQL and Microsoft Access. More work needs to be done in this area as well. Online complaint forms. They varied in which information is required, optional across different California air districts. We're not consistent for California. Vancouver provided basic odor material for complainants, common odor and sources, odor wheels, and investigation processes. They're moving ahead with some of the material that I've been describing. Here's a complaint data management approach. This happened as an example, in the water area in West Virginia about 4 years ago. There was a spill 2 miles away from the odor plant. And people in the whole area were drinking this water and smelling it, and they were asked, what do you smell? These are people. So this is like an odor map. Whoops, this is like an odor map. Look at what they said. Fermented liquid, licorice, sweet as the major areas. Turned out that we got that chemical in our laboratory to evaluate what the odor was and intensity. There were 13 different chemical components. One of them, MCMH, for an acronym, was the major one. It turned out it had this dramatic licorice odor, black licorice odor. Not the brown, not the red, but the black licorice odor, okay? And this caused the plants to be closed. For a month, they were using bottled water in the area. Not only that, it took a month to clean out the water system in their own homes so they can go back to using the water in a normal way. And this was a spill into the water plant. The plant had activated carbon. They thought it would remove it. Turned out, saturated it, went into the district. But that's an idea of how you can use that kind of approach to define to the public what the odor problem is in a particular air district. Okay. 4, screening level approaches in California. Cal Cycle stopped using intensity scale at composting facilities because they stated it is ineffective. They weren't trained. They tried to use a scale. They picked the 1 to 5. They didn't like it. They discarded it. CARB handles mobile source odors offers capacity training, opacity training for smoke, so they could provide odor training using the odor profile method. When I leave this place tomorrow for the next 3 days, I will be at Contra Costa Water District training the people in the laboratory and the investigators out in the system how to use the odor profile method so that they can adjust their treatment at the water plant not to have any odors in their system. It works. Okay. Investigate threshold. South Coast generally, 6 to 10 complaints in 24 hours. We have an odor problem. Bay Area, 5 independent complaints. Placer County, Feather River, all complaints are investigated. So this is the way they go out in the different areas to say, I'm going to go investigate, we got a problem. Different in different places. Should there be a standard in California? Makes sense to me. Method, inspectors verify complaint and they check upwind. They walk upwind to see if the odor stays. Many inspectors, without training, by going out over and over again, have a good sense of smell and can follow an odor going through, but they're not trained on a specific method. Method, inspector verify complaints and check on upwind. Challenging sources, trash transfer stations, metal grinding, composting, rendering facilities, food drying, all areas of major sources of odor. Odor panels, stopped 5 years ago in the Bay Area because the people complained who were doing the odor inspectors worrying about toxic effects. So the relationship between toxicity and odor has to be evaluated. There is data in the literature that shows, besides benzene and naphthalene, where the odor threshold is at a level where it's more toxic than you smell it, all the rest of them, you smell it before it becomes a toxic issue. And there's data in the literature to show that. Odor panels stopped 5 years ago. Odor management plan, ineffective and resource intensive. That's our general conclusion that we've seen in California. Screening levels, Colorado. Colorado, inspectors avoid odor notes and focus on detectability. They use a 0 to 10 intensity scale saying they smelled something and they give it a, so they use the intensity scale without the odor defined. Regulatory limits on field olfactometry. That's a dilution effect. There are places where there are laws that say in Colorado, 2 to 1, 7 to 1, 15 to 1 are under protective. When they did this, they had 2 to 1, 7 to 1, and 15 to 1 ratios, and they still weren't protecting the odor at that particular source. So it doesn't seem to work on the dilution effect because of this cross odor problem. 10-day field studies for persistent complaints they developed using in Colorado. 350 cannabis cultivation warehouses are in Denver. So now requires odor management plan for each. An odor management plan for that could be an odor management plan for a landfill, for a sewage treatment plant odor, for a trash transfer system, whatever. Need follow-up discussion whether training on odor notes and associated key odorants would aid their investigation. That's our conclusion. Australia, dispatch 24/7 in Victoria. They get an odor note, they're out there 24/7. They investigate threshold 3 calls or 5 calls for known sources, trigger an investigation. They're pushing ahead. Method, 2 inspectors follow the grid approach, strong, faint, and none, and 3 levels of frequency and duration. So they've added frequency and duration. So besides odor characteristic, intensity, frequency is critical, and duration is critical. Because some places, like we wouldn't say the manufacturer of a pork product is producing and knocking off the steam from that product at a particular time of day, that's a frequency question, that's a duration question. That's important. No longer use dispersion models. Dispersion models are odor units. Now this, we were surprised at. They've thrown out the idea of the dilution. They've thrown out the idea of dispersion models which work on dilution and usually use H2S as the model. Need follow-up discussion whether training on odor notes and associated key odorants would aid investigation. This is our conclusion from this. I've been working with the Australians over the last 10 years, and they seem to be able to get a lot of money to do this work. They work on chicken areas where they produce chickens, and anybody smelled an area from chickens, you know what I'm talking about. And they found out what the chemicals were, what the intensity is, and how they're working on treatment methods to remove it from the area that this is coming from. Number 5, refined investigation recommendations. Community engagement. Community engagement is critical. That's who the consumer is. You are treating a consumer with a problem. They want analysis of odor complaint data. You have to analyze odor complaint data over the years to see what's going on. Odor surveys, odor diaries developed by people as well as by districts. Community meetings and communication aids where people come out and talk to the people in the area to try to see what's going on. As a suggestion, odor profile method, odor wheel, and intensity training could aid this discussion. The above information could direct which chemical analysis techniques are needed to define the chemicals causing the odor via the odor wheel, and then you go out and solve it. We have looked at this in certain places, and it works. Here's the odor profile method. It's derived from the odor-based flavor profile method, which is a method in standard methods of water and wastewater, APHA. This is from 2012. It started then. It's continued to this day for food and drinking water. Total odor as is, without dilution observed by a panel. Odor notes from the odor wheel. Odor intensities 0 to 12 anchored by the 3 sugar solutions. Cross-modal taste to smell approach. It works. Duration and frequency is a key issue. Limit to 2 or 4 odor notes per mixture by the ability of the panelists to observe odor. Use in food industry to evaluate coffee, wine, juice, drinking water, and in perfume and cosmetic industries as well. This method is the method that's used in all these industries. Here's the way it works. Sugar solutions or sour, salts, bitter, you can use for weak. Let's look at the sugar one. 5% canned fruit, moderate, 10% soda, like Coke or Pepsi. Strong, syrup, jelly, 15%, which represents 4 on the scale, 8 on the scale, 12. 6 and 10 and 2, you adjust by looking at those. And you can do it. I've seen it done all over the world in the drinking water industry. Now, Arthur D. Little developed this intensity scale at the beginning. They said, we can't use numbers. It's not consistent enough. We'll use plus, 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 or plus, 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 or 1, 2, and 3. By doing this, we've broadened the scale and try to make it work. They felt that you couldn't go down and do this, especially at the lower areas before 4. It turns out that the odor recognition by people is about in the 3 to 4 area, so that works. When somebody is saying they're smelling something, they're smelling something in the 4 area. If it's below that, you really need an expert who's pushing it and really can get down to the nitty-gritty to get there. And it sort of indicates what possibilities are that are coming, what to worry about. We have gone more in this direction as more definition. Scott and I have been arguing about whether you're allowed to do it. I say it works, but you're right, there's a lot of inconsistencies, but it seems to work. That's all I'm going to say about it. The first thing you do with an odor panel, you got to find out if they can't smell anything. And this is a scratch and sniff test. It's 40 different common odors. If you get less than 28, then you're almost anosmic, and you're anosmic, and that means you shouldn't be on a panel. I trained San Francisco on this about a month ago. The East Bay Mud area. There was one student who couldn't smell anything. He was eliminated from the panel. There were two who were so good that I said, all the other people, inspectors, go see these two to confirm your odor, because they were right on target. That's the variability you get, but people can understand that. So the first thing is, do that. The challenge, require configuration by analytical chemical methods to define the chemical causes. Results may influence by group discussion despite instructions to give independent results. You're allowed to discuss it, but you don't want anybody to take over. May not be reproducible across odor panels, although reproducible across drinking water, taste, and odor panels. Increased training may help. It's the only method that I've seen work. Similar methods used in dentistry for odor that was independently developed on a 0 to 5 scale. It was amazing. We looked in the literature, and there it was, laid out like it's done in water for dentistry, without any relationship and no comment about anything done in water. So it was an independent development of the same thing. I saw that, I was very happy. OPM, successful use for odor nuisance in published literature at wastewater treatment plants. We've worked at Orange County Sanitation District. Composting, we've published that in WEF. Trash transfer stations, we published that in Atmospheric Science. Landfills, we will be talking about that in Sardinia at a meeting on landfills. Drinking water plants worldwide. So it's been shown to operate and work to define what it is so you can find the chemicals and get the answer. So here's a grid method to go out and look at it. Here's the odor problem. Here's a grid. The wind blows in that direction. Set up a grid to be able to pick people in those areas and go measure, see what's going on. Here's another field panel where you go back and forth and find out, this seems to be the place where the average, the highest odor is. Could be the highest odor, could be the average odor, whichever you want to define, looking for the plume for the odorants. You can take people, start them here, move them here, keep them moving down till they go off screen. This has been done at a landfill operation up in the hills over Marseille in France. So not only is it done in the United States, but it's done in Australia, it's been done in France. Dilution test. Laboratory dynamic olfactometry, or the nasal ranger is in the field, measures pseudo-intensity because there's no intensity value, called odor units. They just call it odor units. Odor notes change with dilution, that's the problem. Mixtures, synergism, and antagonism between odorants change with dilution. That's another problem, is the synergism and antagonism. Primary detect last remaining odorants. That's what you're ending with. You might smell rotten vegetable here, it might be earthy musty, that's controlling at the bottom. Earthy musty may be acceptable, it smells like soil. Where rotten vegetable, you want to cut out. For mixtures, mimic dilution from source to fence line. Here is the olfactometer. Euban finished his PhD working on some of the subjects we've been talking about. He's an olfactometer, is nothing more than a dilution machine, and he's smelling, and it's done using the triangle method to make it more desirable. Guess who that is? That's Scott. He was working the computer while Euban was at the machine. This is Orange County Sanitation District. After our work, that piece of it, that equipment, which is very expensive, is going to be auctioned off. Dilution is unmasked. This was a very important part of those studies. Here, this is what the panel found. They found fecal and sulfur with no dilution, with a little dilution. about 0.7 dilution. Here is the fecal decreasing with dilution. At the end of about 1.75 dilution ratio, you can't smell the fecal. Sulfur, the green, was found simultaneously with fecal. It wasn't found here, but it was found here after the fecal had gone down. Here's the fecal, and suddenly we see musty coming. And musty shows. And finally, musty is the one with 2 dilutions and controlling the influence of the material. Here it was a combination of fecal and sulfur. So this is the dilution, the unmasking of an odor that's controlling the final system. At Orange County Sanitation District, the odor from the plant that measured at the plant was all of these, was the fecal and the sulfur. They went and treated their systems. They removed it. Guess what? The people in the district were complaining about musty odors from the plant. They said, it doesn't smell musty at the plant. You need refined analytical chemistry to back up the odor evaluation. Without the chemistry and defining the chemical, this doesn't work. Gas-specific sensors are available: hydrogen sulfide, ammonia, gas chromatographic mass spectroscopy, that's routine in almost all districts, selected ion flow tube mass spectroscopy, Sift, usually this is a YFT. It's only a $300,000 instrument at present, but it's fantastic. It doesn't use a gas chromatographic column. It goes directly through a column like chemical ionization, for those who understand what that is, using 7 different kinds of probes. It can be done on the spot, and you get real data in real time. Proton transfer reaction mass spectroscopy is similar to the Sift method, except it only uses hydronium or hydrogen ion to do that material. Hybrid, GC sensory or GCMS sensory. What you're doing here is you smell the exit port from a GCMS, or you have a GC system, or you have simultaneously, you do the GCMS, and also you do the GC sensory to define what each peak on the chromatogram is. Non-specific sensor array is the E-nose. That's a possibility that's been looked at. Guess what? There's the ammonia, there's the hydrogen sulfide. Hydrogen sulfide at 0.1 doesn't really get down, just about at the limit where you smell things. It's not very good. There's Euban in front of the GCMS injecting his system. You can't see it, but there's a sensory place right there where people can take a sniff from it if it's set up that way or it's set up to the mass spec. I like to use them separately, not with a splitter, because the splitter gets filled up with material and it sometimes breaks down. Here's the Sift method. The Sift method goes from a plasma to a mass filter to a sample inlet to the quadrupole mass spectrometer, and this is the chemical ionization possibilities, and this is the chemistry that goes along with it. The E-nose. There's the E-nose. It's an electronic representation. That's all it is a bunch of sensors on a plate, 26 array, and they're supposed to array your nose in the different sensors will give you the same thing as your nose does. It doesn't seem to work very well yet. I'm going to leave now the human health risk assessment and rest my voice, and Scott Braithwaite, who is the expert in this field, not me, will talk about it. Scott, you're on.
All right, thank you, Dr. Suffolk. So we just wandered through odor sensations, how we measure it with instruments or human panels. But one of the lurking questions with odors is there are chemicals in the air, so are a lot of hazardous air pollutants and criteria pollutants. Could these odors be triggering health effects in the populations that are observing the odor? So I relied back on the classic, oh, for the pointer, thank you. Oh yeah, the slides too.
This one.
Okay, that one goes
And
forward.
this is the pointer.
Okay. So I went back to the classic paradigm for risk assessment that was promulgated back in the 1980s of how to deal with the question if an exposure to a chemical is sufficiently high to cause adverse effects to a population. The first step is the toxicity assessment, where you first identify the hazards. What are the potential adverse effects that this chemical could cause? Then, as you alter the exposure level, going from high exposures and extrapolating down to low exposures, et cetera, how do you get a dose response assessment? As the amount of exposure changes, how do those health effects change? Typically, as you go to higher concentrations, you're going to see greater health effects from a given chemical. Finally, you couple that with the exposure assessment. Okay, we now understand the toxicity of the chemical, how it changes over concentration, but what are the real-world exposures that a population is receiving, and how do those compare to the toxic thresholds? Finally, you wrap all that up into a risk characterization where you do that comparison. As a simplistic example, I always think of a speed limit. Someone sets the speed limit at 55 miles per hour because that's supposed to be safe for that given road. If cars are driving faster than that, you run the risk of adverse effects, collisions, et cetera. If you're driving at or below that, you should be in the safe zone. I think the same thing applies in risk assessment, where at the end of the day, for health effects, you're comparing the concentration to, for non-cancer effects, what's called the reference dose in US EPA terminology, or the reference exposure level in California terminology. Or for odors, if something's going to exceed the threshold at which it can be perceived, you take that concentration and you divide it by that odor detection threshold concentration. That usually was determined by a panel setting 50% as the threshold. Now, that's not triggering necessarily a health effect on the odor end, it's more of a sensory effect. Coupled into this and woven into this each step of the way, there are various uncertainties. You don't always know exactly how humans are going to respond because you're often borrowing animal data to extrapolate to humans, and you also don't often have precise exposure measurements. So you always want to be upfront about your uncertainties and at the end of the day, kind of undermine the risk characterization and point out all the potential flaws in it. So for now, focusing on odors and focusing on the sensory effects of odors, the Agency for Toxic Substances and Disease Registry decided to jump into the odor arena a few years ago in 2017 and publish some information, which was one of the latest information sources on odors from the federal government. Back in the 70s and the 1990s, US EPA dabbled with odors, and there were some very large reports written, but then they backed off and let the states handle it. ATSDR weighed in a few years ago, and this was their hazard identification based on the sensory effect of odors, that yes, it can trigger headaches being a key one, a brain effect, eye irritation. Now that's also a toxic endpoint used heavily in acute toxicity studies. So with odor adverse effects, be they sensory, it kind of wanders into the more traditional toxic effects arenas as well. Down there for the stomach, nausea being a common effect as well. And you see various effects through the throat, lungs, heart, and then the world of psychological effects, where constant exposure to exposures can lead to even depression and stress effects. They've measured that in exposed populations. At what point that wanders in from a sensory effect to a more traditional toxic effect is debatable. Now that we've identified for odors, I'm not going to go into the whole traditional toxic effects of chemicals in the air. That's a whole nother presentation. So I'm going to keep this a little more odor focused, but we will be touching on that. So for odors, there is dose response. As you go from a low concentration, you eventually reach a point where that first threshold is called the odor threshold concentration, where you can sense something's going on, but you're not quite at the point where your brain can put a word on it. You sense something in the air, but you're not able to clearly identify it. You can't use one of those odor notes from the odor wheels that we saw earlier on. Finally, as that concentration gets high enough, you can finally say, oh, I know that odor. I know that's fishy, or I know it's putrid, or I know it's floral. you finally get a word triggered in your head. And there's a whole skill set there, putting odors into words, and if you're really good at it, the food industry has a job for you. They pay quite well for people who can really put words on odors and be able to do different layers of sensations and flavors. Eventually, as the concentrations get high enough, you get to the annoyance factor where this is really altering your well-being in life, and finally you reach the intolerable, where you have to get out of there. You just can't take smelling that air anymore. So we're often operating down at the odor detection threshold concentration, which is the area that also has the greatest error and variability. Things kind of tighten up as you go to higher concentrations. Yet on the traditional toxicity of chemicals too, you're often extrapolating down to areas where it is highly variable of what's happening in a population. So there is a parallel there. The WHO, I guess a couple decades ago in Europe, weighed in on odors, and they only tackled 6 odorants out of hundreds, if not thousands of odorants in the air that we experience, and decided to set sensory-based WHO guideline values for them. Most of the time, those ended up being below, but once in a while, like hydrogen sulfide, ended up being above the sensory threshold. Sometimes they're more in the middle. Often they track well with the odor detection threshold. At the end of their report, however, they said, going after these one by one and only handling a handful probably is not effective, and we need to find a better way. So at the end of the day, we do that risk characterization, that crude speed limit check, where we see if the exposures are exceeding the thresholds of concern, both on the odor sensory side and on the traditional toxic risk assessment side. So I decided the best way to present this was to go through some actual case studies. I can't cover all the odors in the world, but I can focus in on a few case studies to make this come alive. So the first study was prioritizing odors. These were from sewers across Australia, and they did odor activity values, which is that concentration in the air divided by the odor threshold. And that was able to reduce a list of chemicals that they were going to do further assessment on from a list of 31 chemicals down to 8 that had the highest C divided by ODTC values. Those ended up being primarily hydrogen sulfide and methyl mercaptan as examples. They, however, had to narrow down. You saw before that these ODTC 50 values can be quite large ranges, maybe 1, 2, 3 orders of magnitude. To do this mathematics, they selected 1 ODTC value as their accepted value. And they also excluded some odorants that didn't have any odor thresholds determined. They could have involved a panel, developed their own, but they didn't do that. So they sometimes rewarded odorants that had no data. That happens in risk assessment as well, or toxicity assessment. There's a similar program for cannabis odors where they compared the concentrations of the odorants emitted from bags of cannabis that were being transported, and they prioritized them for further assessment. And they found that it bubbled up to the top of the list some odorants from cannabis that were not considered by most researchers as the most important. So it was informative that way for future research. So this is just prioritization. This didn't deal with the toxic effects of these compounds. They could have. Now on the flip side, in Southern California, there were intermittent complaints of kind of a hydrocarbon odor that was coming, presumably from the ocean, that was the wind direction, everywhere from Seal Beach down to Huntington Beach, and it was happening over a period of time, and the South Coast issued a whole report where they monitored this, I think there's definitely a 6-month period intensely and maybe a year of data. They actually did monitoring to try to figure out what is happening and when and what compounds are the culprits. They did a risk assessment for the toxicity of these compounds, but they never compared to the odor threshold concentration. They didn't do the sensory approach, so there's no odor activity value generated. For their acute health risk assessment, they found that these various compounds were all below the acute REL set by California. Hydrogen sulfide does have a sensory-based standard in California of 30 parts per billion, and that level was below that as well. Benzene, the period that they issued the report on, none of the values exceeded the acute REL, but 3 later results outside of that data set did slightly exceed it, or sometimes factor 3. On the chronic health risk characterization, they said that their monitoring was not over a long enough period to justify a chronic health risk characterization. There is a challenge always dealing with benzene because in most urban environments, it already exceeds the levels set based on the cancer endpoints of the REL, or excuse me, that's the non-cancer, the REL of 0.9 parts per billion, and the regional screening level that includes cancer effects of 1 part per billion. So you're already in a difficult area with benzene when just kind of your background urban environment already exceeds that level. Our next case goes to Denver. We're north of Denver. There was, again, this random odor of tar, kind of asphalt smells bothering a neighborhood. It was an economically impacted neighborhood, and US EPA had funded an environmental justice study there. So they did 7 months of sampling and looked at 24 analytes. Benzene and naphthalene exceeded the thresholds, yet were considered within normal ranges for urban air. So again, is this challenge where they're exceeding the toxicity thresholds, yet that's happening in every urban environment pretty much. So I decided to not necessarily trust, this is the study from north of Denver, to trust the various points of comparison against their odor thresholds and their health thresholds for these. So I decided to look at other sources of odor and health thresholds. So I looked at the American Industrial Hygiene Association 2013 in the second to last column to see how those odor thresholds compared to the ones from the study in 2015. And it didn't really change the story too much. It did find that down in the bottom for naphthalene, that the lower end of the range incorporated some of their values or their maximum concentration. So it did bring that into the range of the odor threshold. And then I looked at California's health thresholds and found that benzene did exceed those values, the 1.6 value that they measured versus the 0.9. And then down for naphthalene, the 1.7 chronic REL was exceeded by their measurement of 25. So no big surprises by using more California specific or other sources. As I warned, uncertainty is always a factor in any of these assessments. Even though on that previous screen you see lots of single point values, there's usually a range in any exposure measurements, as well as there's a range you saw in the odor thresholds, and in real world there's a range in any reference concentrations too, that boil down to a single value. Whenever they do these studies, it's usually looking at maybe 6 or 10 or 12 or up to 20 odorants, but you're never capturing the full list of all potential odorants. It's a subset, and are you missing the key ones that are driving the odor complaints? And the odor symptoms are self-reported. There's the human factor involved when people are complaining with odors and complaining with the health effects, the sensory effects as well. All right, so I'm going to run through some of the high-level conclusions from our white paper, and then Dr. Suffolk's going to go into more of the best practices, the kind of to-do list that we would suggest going forward. So no single approach seems to work for odors. You can't just use instrument methods, you can't just use a panel, you can't just always deal with the complainants and the air inspectors. It takes multiple approaches to really tease apart the more complex odor complaints. A tiered approach seems to be the most logical. Most air districts start with a screening level approach. They send 1 or 2 air inspectors out to the field to verify the complaint and work with the complainant, and if they can identify the source and it's clear cut, your job is kind of done. Often, you have to move to a more refined assessment where you're going to involve a sensory panel and you're dealing with intermittent odors. The odor wheel and intensity out of the OPM are very effective aids. At the end of the day, you do, however, need to confirm with analytical equipment so that you're targeting the right odorants and solving the problem. Quality control is also a key thing. I find Many air studies are very good in their quality control, doing their blanks and their field spikes and replicates, and odor tends to be a little sloppier and needs to follow the same procedures. So our research needs, in conclusion, the odor units and dilution-based thresholds don't seem to work. Colorado weighed in that way, Australia, and there are examples in the United States as well. WHO report I just talked about says move away from odor and irritant limits toward population assessments. We're actually dealing with the people complaining and impacted and using them as your sensor bank. So the straightforward initial investigations only need complaint confirmation, I just mentioned that, and source identification and doing your upwind check. Refined assessments need more training on the odor notes, using that odor wheel and intensities to identify the problem. Your best approach is to map odor changes over time. And they've done that a lot with noise complaints, I guess because decibel measuring equipment is easier than odor. Doing the grid method and the plume method and verifying with instruments. You need more straightforward guidance on odor assessment. Focusing our research on total odor perception instead of doing these dilution techniques to the last remaining odorant, odor notes and their intensities, measurements of population annoyance I just mentioned. Odorant behavior in mixtures is always the challenge because rarely are we dealing with a single odorant. And our real world E-nose is coming. There is progress in the laboratory setting. They seem to work. As soon as you put them out in the real world, humidity, other factors seem to not enable them to work. In Australia, I finally saw a report where in chicken coops, their electronic nose was working great, identifying the odors inside the chicken coop, and then they took it outside and it just didn't work anymore. There's still a hope that we will mimic the human sense of smell with sensors, but it's definitely a research challenge at this point. South Coast looked at E-noses back in their report in 2000. So I will let Dr. Suffet take over and give you the to-do list.
So this is trying to put it all together in terms of recommendations. You've heard all of this in detail. I'm just going to go over some specific recommendations as what happened. Oop. I guess the recommendations will have to be done later. What I'm trying to do in this section is sort of take the whole picture and give ARB the idea of places to invest their money properly so that we can solve problems better throughout the state of California. That's basically what I've been trying to do. Scott, what slide number is it? Stop. No? Okay. Best practice conclusions, recommendations, best practices, and summary of the research needs. The goal of the investigation should be identify the source and culprit chemical. What is the odorant? What is the chemical? Key descriptions, odor notes, intensity, frequency, and duration. Those are the key words we got to follow. Which chemical causes the odor? Chemicals, not chemical usually. This leads to optimum mitigation procedures. There are methods out there at the sewage treatment plant. You can use activated carbon, you can use trickling filters, you can use biofilters, but you got to know how they work for these kind of chemicals. Nobody has done investigations. We've done some at Orange County Sanitation District. They were presented but haven't been published yet. in terms of biotrickling filters, doing a good job on earthy musty, which we were very surprised about. But this is the kind of thing you got to do the experiments for. Complaint data management, best practice, Vancouver's approach. Educate the user, OPM using the odor wheel and intensity, frequency, duration, and wind direction, train call center operators. Train the call center operators to ask questions. What do you smell? What is it like? How long does it last? About the key instances. Get a plan to develop this. Get a database set up. The San Jose AQMD has a good database for all its districts. Maybe that should be replicated throughout the state or as a state idea. Provide trends and complaint frequency data for suspected sources to air inspectors so they know what to expect when they go out to a place. Agree among air districts, consistent disclaimers and into the public required by laws to avoid confusion. In other words, consistency between the air districts will help all air districts solve their problem. Everybody is taking forms in different way. You need a data management demonstration project to consider both the odor wheel and model databases for a unified approach so that each one could learn from each other and the whole state could do a better job. So that's the research need that comes from best practice. The best practice really is research in itself. This sort of summarizes it. Initial screening of a reported odor nuisance. Initial screening of nuisance odors. We saw that two trained OPM, odor profile method air inspectors were best. That may be the way to go after it. Corroborate the source of odor identified by the complainants and the air inspector by standard practice to move upwind. First mistake I've seen, the likely source of assess other odor contributors. Okay? Document the wind direction in detail. A study of single versus two inspectors to see if a second inspector is beneficial. That could be included in a study. Train air quality inspectors. Train all air quality inspectors on the OPM for anosmic and odor characteristic intensity ability, for consistency across the air districts, retrain every 2 or 3 years, work well with all water districts for odor control. 30 years through that work in water, it works. I've just converted everything I learned in water to look at the air problem. We had a TON, threshold odor number in water, which was a dilution thing 30 years ago. It was proved it didn't work. The odor profile method does. The same kind of thing is happening in air. Develop a log of complaints, prioritize the nuisance. A residential panel, trained minimally, can help. We've done this in the water. The people who complain the most, get on a telephone, call up, send a postcard, whatever you want, get a database on the complaints and then the inspectors, and you got a combination that when you go to a meeting of the community works. Research need, develop air quality training system at one district, then redefine with a statewide rollout. That's the suggestion. Evaluate mobile platforms to see how they can help this. That Sift method and the PTR method, mass spec with OPM if toxic emissions are not expected. The toxic emission data that was shown really disturbed me when they showed benzene is above a potential limit and naphthalene may be, and nobody's worrying, nobody seems to be doing anything about it, and they are below the odor threshold concentrations. And those are the only two that we see in that scenario. All the rest of the odors are above, are not a problem related to toxicity. And there's data in the literature that shows that. Multiple overlapping odors. No proven method for apportioning overlapping odors. Current challenge in California, Milpitas We're going to be working on that with the San Francisco group. Research need, new research methods, OPM with GC sensory and GCMS is needed. Your laboratories can do this. I've been in the laboratories at South Coast. They have the equipment, they could do it. To put a sensory port at the end of a system is easy. There's loads of them. The food industry does it routinely. Refined odor assessment, best practices, instrument sensory methods available, but no standard approach to identify odor sources. Nobody has put this together in a standard approach. Here's the way. If a district wants to change it after the standard approach, fine if they have justification. But you gotta get down to standard approaches so you can get to the problems. The sewage treatment plant in the South Coast and San Francisco is not gonna be much different. Okay, research needs. Whoops, too many of them are listed here, so I'll go through them quickly. Standard protocol, logic flow diagram, including OPM, GCMS, GC sensory work, focus on chemical odorants, not total odor or dilution. Standard approach for odor panels and local residents. Intermittent odor problems, needs sensitive time methods. The Sift and the PTRMS with the odor profile method can be used for that purpose. That's a good example. The eNOS, I say, remains elusive, often failing in the lab, failing in the field, but okay in the lab. Sometimes it fails in both. Research synergism and masking among odors is a goal. I showed you the problem with that. That has to be studied. Temperature and humidity effects require more research. That hasn't been really looked at. Develop odor diaries and plume monitoring. That's another thing that really hasn't been looked at. The plume monitoring could be done with these if they are developed properly and the cost goes down or somebody has the money to buy it. Design annoyance surveys for variability of people. You can do this. You can design a survey. What is bothering the people? You can do the surveys. I've seen people in the South Coast who complained so much about a particular landfill that it became a major project at South Coast. And the landfill then started to develop methods to control their situation because of the bad publicity. But the people in the community really, really were there. You can develop their knowledge and use them as part of the system here to get the best survey. Design an annoyance survey for the variability of people as part of that. Develop odor concentration nuisance maps as noise maps are done. That's something that can be done. Mobile platform mapping and provide meteorological data. I've left out the meteorological data. Obviously, everybody knows that's a key to the whole system. And that part of the system, I think we know how to do. We have the air stations. We can do that. And now you got to see how that works with the other part, with the evaluation of the odor and the chemicals. Human health risks, best practice. Odors add a substantial layer of complexity to human health risks. The inter-individual variability in human response to odor adds a large degree of uncertainty. This is the problem. However, several case studies show OTC and health hazard benchmarks can apply to odorants to estimate sensory and health effects. Scott did an excellent job showing some of that. He showed stuff that was with odor, stuff that was with toxicity, but nobody put them together. Weird. Research, how well this odorant by odorant approach addresses the health risk to communities, especially those suffering from environmental injustice, is an area to need further research and objective methods. That's the idea. More studies like the single experiment that Schiffman did with swine odors, where he was able to follow the odors, but he didn't follow the chemical hazard problem from the swine area. Some physiological and psychological responses are needed to measure simultaneously. This is where the public comes in. Public health people can be involved with that as well as the airborne. Thank you again for your time and patience, and nobody fell asleep. I've accomplished something. When I have a class and somebody falls asleep, somebody in the audience who took a class with me knows what I do. Go out and get a drink of water. I didn't have to say that one time. I'm happy to be here. Thank you.
Okay, well, thank you, Mel and Scott, for a very nice talk. And a lot of work obviously went into this paper. It gives us at CARB a lot of possible avenues for future research. And I hope it encourages like a lot of districts or a organization like CAPCOA, which works with all the districts to work together and hopefully get some databases so they can have some coordinated effort and maybe some standardization when it comes to odor complaints and odor monitoring. I guess, first of all, do we have any questions from people inside the room?
Scott, join me.
I'm sort of I'm wondering how you have panels of people, and you've described the spectrum of someone who has no sense of smell, and at the other end of the spectrum is someone with exquisite sense of smell. To be honest, I'm not sure. Do you want a panel of that's mixed, or I thought the Japanese focus on the people with exquisite. They identify these people, and they're literally hired, much like some people in perfume business or food business will hire these people to be their hound dogs to smell out, to find the odor.
That's an interesting question. It turns out when you train a panel, you're right. There is some people who have a higher sense of smell, some people have a lower sense of smell. The people who have a higher sense of smell adjust themselves sort of to the rest of the panel. They say, yeah, everybody's calling it a 6. I'm calling it an 8. I'm going to adjust my scale to be in that lower range. So there's an adjustment that occurs within a panel. That's an interesting phenomenon, but it does occur. Now, the method for dilution, they pick people with an average sense of smell selectively as their panelists. They don't pick the highest, they don't pick the lowest, they pick the average. In the odor profile method, by the training, everybody sort of comes to this kind of idea of how they are going to compare to the rest of their panel, and it becomes a consistency. That's what happens in the food industry, perfume, coffee, etc. But it's an interesting problem at the beginning. We've had some people with very high and some people with very low sensitivities. If they are very low sensitivities and they're anosmic, they're not on the panel, period. They're gone. But in the middle case, everything seems to fall into that situation. I talked about, we trained 12 people at East Bay Mud. One person was off the panel. 2 people were excellent. They could identify character. The intensity was more of a problem, but they adjusted their intensity with the other people, and we got consistency by putting the notes down on the board after the training period and doing testing. So it works.
Just one more thing on that. The state of Colorado trains its air inspectors every 3 years on odor intensity. And yeah, if they're too insensitive, they're excluded from doing odor work. And if they're too super sensitive, they're also excluded.
Yeah.
So they try to bring in the extremes.
Actually, I have one quick follow-up question for that. Let's say you have an agency or a district who doesn't have one of these set up and they want to start a training. Are there organizations to do this, or how do we get?
I'm a one-man organization,
Yes.
but there's a lot of other people who can do this. Metropolitan Water District of Southern California has people who've done it. The Australians I've taught them, they've done it. I've taught people how to do it, so there's a lot of people around the world who can do it right now. This is used in China, Taiwan, some places in Japan, all over Europe, especially France and England. In Brazil, they have an odor panel that operates this way. Argentina does it as well. So it's all over the United States, all over the United States.
Thanks.
But the state of Colorado also allows outsiders to come join its trainings that go on like once every 6 months.
But on the training kind of thing, You could, a training kind of thing, there's another thing which I haven't mentioned. You could collect, the inspectors can collect bags, Teflon bags, which doesn't absorb any of the odor, bring it back to a panel at the air location at the lab, and you could have a panel set up at the air location and do it. I get samples from all over the world. They send them to me, and I have an odor panel that measures it and does it for them. We did this in Orange County. They sent us samples. We're going to do this in Milpitas. They'll send us samples. So you can do that. You got to get the samples quickly there within, we like to be 8 hours. If it's 24, we suffer. Some of the things that have been used in the past have been allowed 36 hours for the odor dilution. And we know absorption occurs within 6 hours to Tedlar bags for fecal, so they were measuring incorrectly.
Thanks.
So you can do it that way.
Very interesting talk. Thank you for coming up and giving it. Maybe this is more of a trivial question, but when you're training these individuals, and you say some would be anosmic, is that a sensitivity that they don't smell it, or they smell it but they can't put their finger on exactly what it is they're smelling?
No, they can't smell because it's called an upset test from the University of Pennsylvania. Dr. Doty developed this method. He uses it for odor for patients because certain diseases, people lose their sense of smell. So he actually uses it in medical science as well. These are very common things that everybody knows, and if you can't identify at the level we're talking about is on a 6 to 8 on the scale basis, if you can't identify at that chocolate or cinnamon, you got a problem.
But
So
it is a scratch and sniff
scratch and
test, and
sniff.
so it's not so much about intensity, it's be able to putting the right words with what you're smelling. And
Right.
if
And they give you
something is supposed to be
choices.
chocolate, but you think it's raspberries, you're not quite on target, and you can't use the odor wheel effectively.
But you have 4 choices to pick from, so they give you every possibility of getting it right.
Colorado does more intensity checks on its, so it doesn't use the odor wheel. Colorado uses their 0 to 10 intensity scale and has its own methodology to test the.
Thanks, Mel. Thanks, Scott. A couple questions. So first, is there anybody doing or continuing the work that Jane was doing with identifying the chemicals and then associating with those? Okay.
Scott has been doing it, and Euben, who just graduated a year ago, was doing it with publishing some of those papers, yes. And Gloria Bian is doing it right now, and worked on the landfill project. So if we have a project and I have a student, we can get the work done. It's that simple.
And also regarding the training, how long does that take to do like an OPM panel? So you're going to be in Contra Costa for 3 days. So is that like the standard training
Well,
time
Well,
for doing a
you
panel?
you can beginning to train a panel over a 3-day intensive, 3 to 5 day intensive period. You only can use like mornings each day because after 3 hours you're saturated, okay? But, so you can train a panel for that. Then you bring them back, you give them real samples and you evaluate and you see how they're doing. And then you come back a month later, let's go through retraining. You can see by seeing the data where certain people aren't doing as well as other people. Eventually, within, I'd say 3 to 4 months, they're trained pretty well.
And then how
It takes a while. If you ask anybody in any of the industries, the coffee industry, et cetera, and I learned some of this from a guy next door, when my first job at Drexel University, who was a coffee taster. And he described it. He says, that's why we spit out the coffee, because we don't want to keep it in our noses, et cetera.
Well, so how does that compare with, say, if you wanted to train a
In
community
water?
member? Like,
Me?
if you wanted to go and train a community member? How
In
is that different?
Chandler, Arizona, we had some people come in from the community who was the ones who really were upset about the water. We brought them in, we trained them, and they were sentinels. And they turned out to be sufficiently understandable of what to say to tell the operator or who was collecting the data, what was going on. And that took like a 2-day training, and then coming back a month later and seeing how they were doing versus the panel that was always operating. So you can train them versus the panel and see how they're working. It's a progressive learning experience. It's a learning curve. But you're a great wine and beer taster when you threw this on a personal level.
Thank you very much for this very interesting topic. And this is really new to me. This is my first time listening to odor-related topic, you know. So this is a very basic question, maybe. For the odor wheel, is this very specific to a city, or is universal for any urban city?
The urban one?
Yeah.
The urban one was general to what was the data South Coast developed. Now, if we looked at data only from San Francisco or San Jose, it might be slightly different, but I think the basic topics were there.
Okay.
Some may not have one particular thing in their wheel, but as a general odor wheel, looked at Vancouver, they did it, looked at the way we did it, they're very similar. Some of the wording may be different, but it's very similar. And there's no standard reference for this kind of thing. So we've developed, it's in the appendix, landfill wheels, sludge drying wheels, compost wheels, because each one has a different set of odors that are controlling. And on the compost, we have the good odors and the bad odors. The good odors are in green, the bad odors are in brown.
Thank you. And also for the wheel, so I think they are different, like different wedge has different size. So what does that size mean?
So you have the inside general, then you have more specific, and then on the outside, you have an actual chemical that has that odor from the literature, or you do it ourselves, or that chemical has been identified as an odor problem. Usually there's a star next to it, identified as an air pollution odor problem from a wastewater treatment plant.
But the actual size of the wedge
The
doesn't
size
really
of the
mean
wedge
anything.
doesn't
It's
mean
just a
anything.
graphic. It's turning a table into a cute round graphic.
Yeah, and if there's a lot more chemicals in one area, that means the size gets bigger.
Dr. Suffet and Scott, thanks a lot for all your hard work. I think this is a great white paper, great overview. Obviously, all of the OPM methods are still pretty subjective, just based on what people think they smell, even though they go through a rigorous panel. Being more of a measurement guy, I think my question really is, are you working with any vendors to come up with an analytical suite of methods or a new set of instrumentation, short of the eNOS or something more analytical?
All of these chemicals have been tested on eNOS. And in fact, I was in France on a sabbatical at Suez Environmental in Circe, and we actually tested the chemicals on a particular eNOS, got a response, and said, okay, we're going to put mixtures in, you get the same response, and we weren't getting the same response. It was never published, but that's what I've seen.
But I guess my real question is, do you have research planned to work with vendors to develop quantitative analytical methods versus just the panels of people?
Okay, the standard method in drinking water and wastewater was done by a whole group of compilation of people all around the world who have done this, okay? And in that there are standards listed for each type of odor that have been observed, okay? That's been done in water. It has to be done in air. Some of them are complementary. You know, in water, really, you're smelling air. You're smelling the headspace. When you drink something, your nose is getting the headspace. That's why when you drink wine, they give you a big sifter, because they want you to get more of the headspace of that odor when you're drinking it. Beer does the same thing sometimes. So when you are really doing water stuff, you're really doing air stuff, okay? When you taste, there's only 4 simple tastes. Sugar, sweet, right? Sweet, sour, bitter. What did I miss? Sweet, salty.
Umami, or
Those are the 4, that's it.
Now, what's your opinion of the future of Sift MS and PTR MS in odor investigation?
I would love to get a hold of that equipment and use it to verify what you find by the odor profile, what you find by GCMS and GC sensory, take the whole picture, and now you put the Sift at the location you want to see that's causing the person the problem, you're causing the area of the problem, and follow it time. Now you get frequency and duration, which you can't get because we're taking grab samples. So when you're going out and smelling something, you're taking grab samples. So that's where it really would be. It's like putting the whipped cream on the cake. And it would make it, then you can go to court and verify what you have. I think the GC sensory and the GCMS can verify to a certain point, but it's only a grab sample. Now we got duration and frequency. That's where it's fantastic.
Okay, thanks. We actually have quite a few questions from online. The first one's from Dennis Froelich, is from the Wastewater Reclamation Department in Tucson, Arizona. It's directed towards Scott. It's basically asked, how would you address the desensitization of the nose from prolonged exposure to higher concentrations when discussing the use of odor perception with risk avoidance of toxic odors?
Yeah, that's definitely known in odors that as your nasal neurons receive the message that, oh, there's an odorant here and there's enough of that to start triggering them, then once the message has been received, they do habituate and become less sensitive typically over time. Once in a while, people can become more sensitive to odors over time, but usually after the signal's received, your brain, after about, 1 second or so, as quick as that, 1 or 2 seconds, can adjust itself and say, okay, message received, I don't need to over-focus on this anymore. But with our sensory panels, we definitely develop those numbers for that first hit of an odor and for those first 1 or 2 seconds. And so those take into account or avoid that desensitization that can happen over time.
We took into account this in the landfill project working at a school. The panel sat in an air-conditioned room. They went out to the playground at an area for 2 minutes, whiffed, went back to clean air. That's the way to do it. I don't recommend taking an oxygen tank or something with you to clean your nose, but that's how it has to be done. If you're in an air-conditioned car and you go out and come back, that's okay as well. But if you're exposed too long, you lose your sense of smell, and I think everybody has seen that.
That happens in the workplace, especially. Workers
Yeah.
often.
Right. And I guess
Can
that
lose their
kind of
sense of
is
smell over
where the
time.
question's going. With this desensitization, do you think it ever lead to just a hazard due to the fact that you don't smell it, you won't avoid the toxic odors anymore?
That can, and typically in the workplace, industrial hygienists don't let the sense of smell be a protective mechanism because people have various sense of smell. Some people are anosmic. You can't rely on that. It is a nice bonus sensor, but it can't be ever your primary sensor, and it does in workers diminish over time.
Okay, thanks. We have a question from Caroline Vega from Chile. Yes. So thank you for joining us from Chile. I guess the question is, for the handling of odor complaints, can they use complaints like a noise map?
They can use a noise map approach to get the complaints and list the complaints the same way a noise map lists complaints. That would be the way to do it.
The people we talked with in France are really pushing for more odor maps to parallel noise maps. And they tried to insert that in some legislation over there, and it didn't quite take. Yeah.
Okay, and the other, maybe a question either for you or maybe for agencies to figure out later on, how can we harmonize using the best instruments and sensory methods in working with local residents around odor complaints?
Yay, team, let's go.
Okay, yeah, I think that's something which, because agencies like ours do work with local residents, we get complaints, and then we have other agencies with instruments, and that's probably something we will have to try to figure out in the future afterwards. Do we have any other questions from the room? And no more online? Okay, I'd like to thank our two speakers again, and hopefully we get to work with you guys again soon.
It's been a pleasure, thank you.